Hello there everyone, Mr. Hall here, and today we are going to be working on converting an improper fraction over to a mixed number. In fourth grade, we use improper fractions like, let's say, 11. You know what? I'm going to move this over to the side. It'll make it a little easier for us. 11 fourths. When we're doing math, because it's easier to calculate when we're using improper fractions. But when we're done with it, we usually want our final answer to help make sense in the real world. Mixed numbers, when we convert over to them, they show us how many whole objects we end up having and how much is left over. And it's much easier in a real world context to understand. Let's say I'm ordering pizza. Instead of saying, at the end of a party, I have 18 slices of pizza left over. No, I could easier say I have 2 whole pizzas and then half of another pizza left over, or whatever example it is. Now, in the real world, mixed numbers make much more sense for us. So taking an improper fraction, which is where our numerator is greater than our denominator, and converting it over to a mixed number helps us understand quantity, explain our thinking, and check to make sure that our answers are reasonable, okay? So let's take our 11 fourths. And what I want to do, we're going to do this in 2 ways today. We're going to do this as decomposing our improper fraction into its whole parts. And then we're also going to learn a shortcut using division to help us out, okay? So if I have 11 fourths here, sorry for the camera shake there. What I want to do is ask myself, how many 4s can I take out of the number 11? And I think about it, and I know I can at least take 1 away. So I'm going to come over here, and I'm going to write 4 fourths. Remember that when we are taking away 4 fourths, what we are actually taking away is a whole number. We want to find our pairs, our buddies, where our numerator matches our denominator. So I can take at least 1 4 away, and if I do that, I ask myself, what's 11 minus 4? And I get the answer of 7. So I think, okay, could I take another 4 away? Well, 7 is larger than 4, so yes, I can. So I go ahead and I take another 4 away, remembering to bring my denominator along with me. And now I am left with, I had my 7, I took my 4 away, so now I have 3. I could reverse it as well, and I can ask myself, okay, 4 plus 4 is 8. How far away am I from 11, which is 3? I ask, can I take another 4 away from 3? The answer is no, so I go ahead and I write what is remaining, 3 fourths, okay? So now what I want to do is look at this, and I'm going to ask myself, okay, how many whole numbers do I have? How many buddy pairs do I have? And what I like to do is represent my buddies by using a 1, represent my wholes by drawing that it is actually a whole. So I come in here, and I'm going to go ahead, and I'm going to draw a huge, giant 1. And I always encourage my students to do the same. It's just that they visually recognize that when a whole number, or when a numerator and denominator match, that is 1. It is representing 1. 4 divided by 4 is 1. That is 1 whole pizza. If I cut my pizza into 4 slices and I have 4 slices remaining, I've got a whole pizza available to me. So I like to draw the giant 1 on them so that I can represent, hey, those are my 1s. And it makes it a lot easier to ask myself when I'm converting to a mixed number, okay, how many wholes do I have? Or how many 1s did I draw? And I look and I say, oh, okay, I have 2 1s. What is my fraction remaining? 3 fourths. So 11 fourths is the same as 4 fourths plus 4 fourths plus 3 fourths, or 11 fourths is the same as 2 and 3 fourths, 2 wholes and 3 fourths remaining. Let's go ahead and take a look at how that would work using division. It is a faster way, but it really requires you to know your division facts. All right, so let's take a look at the same problem, 11 fourths, and let's see a faster way to do this, okay? So we have 11 fourths, and really what we're doing, even when we're decomposing the numbers and breaking it apart, is we're doing addition. We're doing division. We're doing repeated subtraction to find ultimately what a quotient and a remainder is. So we can skip all of those steps and we can jump straight to division. So what we're going to do is we're going to go ahead and we're going to say our 11/4. Well, what's going to happen here is our 11 is going to fall down, all right? The 11 falls off. And when it falls off, it's going to change the problem from 4 or 11/4 to 11 divided by 4, okay? So the 11 fell down, the bar fell with it, and then a little roof was put on top. I don't know, however you want to look at it. So now we have a division problem. We have 11 divided by 4 in standard algorithm. Whenever we work with division, it's always a good idea to go ahead and set ourselves up with our TB chart, our tops and bottom chart, if you remember from our division videos. Our T is always going to be 0 through 9, so we go ahead and we list, if I have room, 6, 7, 8, and 9. And then on the right-hand side, so this is our top, 0 through 9. Our bottom side is going to be our multiples of our divisor, which is 4. So I go ahead in here, and we got 0, 4, 2 times 4 is 8, 3 times 4 is 12. Then we have 16, 20, 24, 28, 32, and 36. And you can see where knowing your multiplication facts is going to make things a lot easier for you if you're able to list your multiples of your divisor. So now I can go ahead and start working on solving this, okay? So I have my 11, and I'm dividing it by 4. So what I want to do is I want to look at my bottom and see how close can I get to 11 without going over. So I look at this and I see, okay, 0, 4, 8, 12. 12 is over, so the closest I can get is 8. So that's going to be my bottom number, and I find my match, my T, that is my top number. So 2 is going to go onto the top. 8 is going to go onto the bottom. I'm going to go ahead and subtract those from each other. 11 minus 8 ends up being 3. And then I do the same thing. I ask myself, how close can I get to 3 without going over? Well, I look at this and I say, okay, 0 is under, 4 is over, but there's nothing in between. So I'm done. I'm done with the problem. I have brought everything down. I have taken care of every place value. I cannot divide 4 into 3. So I have finished with the division portion. Now all I need to do is bring this back up top and set it as my fraction. My 3 is going to be my numerator. My 4 is going to be my denominator. And so I end up with the answer of 2 3/4, just like we did a few minutes ago when we decomposed our number into wholes. Let's take a look at this again with one more practice problem set. All right, so let's say we have 17/5, and let's decompose that into its wholes. I'm going to ask myself, again, how many 5s are in the number 17? I know for sure there's 1, so I pull that out. I know I can do 2, because 5 plus 5 is 10, 5 plus 5 is 10, so we're getting closer to our 17. I'm left with 10, which means I have 7 remaining. I can pull another 5 out of that one, so I can pull that. So now I have 5, 10, 15. My goal is to get to 17. I can't do another 5, but I can do 2, so I pull that out, okay? I then go back through and I mark off all of my matches, my little buddies, and I draw a big giant 1 around them to represent that those are my whole numbers. Go ahead and do that. Now I ask myself, how many whole numbers do I have? 1, 2, 3. What's remaining? 2/5. Okay, so 17/5 is the same as 5/5 plus 5/5 plus 5/5 plus 2/5, which is the same as 3 wholes and 2/5, 3 and 2/5. This strategy works fantastically, by the way. The students love to use this. Where it becomes a problem is when you have very large numbers. Say you had to decompose 83/5. Well, then you have a problem. Then you're starting to get to way too many whole numbers, way too many things to keep track of, and it just becomes a lot more complicated overall, which is where the division strategy is going to be superior. But for small numbers like this, I always encourage the students to break it apart. It really gives them an understanding of what the numbers mean in the first place. So let's take a look at this one again in division, and then we can wrap up this video. All right, so again, we have 17/5, and like we did last time, our 17 is going to fall over, and we're going to end up like this. It fell over. It just turned on its side. We put the roof on top. So now we have 17 divided by 5. We come over here and we do our TB chart, just like we did before, listing our T's. Our T is always 0 through 9, so you don't have to worry about that. 6, 7, 8, and 9. Then we list our multiples of our divisor. In this case, it's 5. It's 0, 5, 10, 15, 20, 25, 30, 35, 40, and 45. I'm going to go ahead and I'm going to look at my 17 and I'm going to ask myself, how close can I get to that? So what I want to do is look for the one that's past that, okay? So look for 17. What's past it? Okay, 20 is past it. So what's the step right before? 15 is 3. So we're going to go ahead and put our 3 here. 15, and we subtract. We end up with 2. I ask myself, what's past 2? Well, 5. So before that is 0, I'm done. I go ahead and I bring my 2 up, and I end up with 2/5. 3 and 2/5, just like we did in the previous problem. So yeah, that is converting an improper fraction over to a mixed number. A little bit more work than converting a mixed number over to an improper fraction. But mixed numbers are generally easier for us to visualize. It helps you catch mistakes too, because if somehow you did this and you ended up with an improper fraction there, it makes it so that you know that it's wrong, or it helps you understand what the number actually means in context, so you don't end up with 42 pizzas for some reason when you did 17/5. You should be able to help catch mistakes. The biggest thing, again, to avoid, the denominator stays the same no matter what. Whichever problem, whichever way you're doing this, the denominator stays the same. Division works with larger numbers. It makes it easier when you have larger numbers. Decomposing, I find easier when you have smaller fractions. So yeah, anyway, that's it for converting an improper fraction to a mixed number. So thanks for stopping by. Thanks for watching. We will see you in the next one. Take it easy.